Albedo, it has a lot to do with our weather, that's for sure.
Yeah, there's a lot of snow on the ground right now, record amounts of snow, and with all the snow, it's very bright outside. You often need your sunglasses with that fresh snowpack and record amounts of snowpack. So if you look at just this calendar date, or yesterday actually, because of how records are kept, 19 inches on the ground at the Bismarck Airport. That's the most for March 21st on record. And if we look even more into the future, the latest snow depth with latest date with 19 inches or more of snow depth into spring, the only date in history with snow on the ground of this magnitude later in the spring would be back in 1975 when we had that spring blizzard. But in terms of this year, we've got a little ways to go to set a new record in terms of that. However, for snow depth in terms of consecutive days with more than 8 inches of snow on the ground, we have 132 days with more than 8 inches on the ground, getting all the way back to Veterans Day last year, and we're chasing the record for more than 1 inch of snow on the ground, and we have a record of 150 consecutive days with at least an inch of snow on the ground from 1978 to 1979. We have 133 consecutive days this snow season from last year into this spring. So a lot of snow on the ground across the upper Midwest, more than 2 feet of snow on the ground in many locations, pretty much all of the Peace Garden State with more than 1 foot of snow blanketing the landscape. So on satellite imagery, if you look at the state of North Dakota, it's practically covered with white with all the snow that we have on the ground. And that's very reflective, meaning it has a high albedo. So that's our weather word for today. Albedo is a measure of how reflective a surface is. It's derived from the Latin word albus, which means white. So a high albedo, clouds, ice, or snow, all of that incoming solar radiation, the sun's rays, gets reflected, or a lot of them get just reflected back out into space because of a very white surface versus a darker or even a very black surface. All of that solar radiation, or at least a lot of it, just gets absorbed, and that's a low albedo with a darker surface. So it's a 0 to 100% scale. Higher albedo means more reflective, as I said, but the amount of sunlight absorbed by different surfaces, that's the driving force for our weather, because that can form atmospheric circulations with a warmer surface compared to a cooler surface, ground versus oceans, etc. So a list of terms of how reflective a surface is compared to how much solar radiation it absorbs. So an ocean has a very low albedo. A lot of that incoming sunlight just gets absorbed. Same thing with forest, because we're of a darker landscape. A lot of it just gets absorbed with the surface. Then we go up towards deserts and higher level cirrus clouds. That has a little bit of a higher albedo, meaning it's a little bit more reflective, but still we can get some absorption from those surfaces. Whereas lower thick clouds, a lot of the incoming sunlight just gets reflected back out to space, as well as our fresh snowpack. This is a picture from my recent trip to Utah when there's a lot of fresh snow on the ground, bright sunny day, a lot of that radiation just gets reflected back out into space. We have a very high albedo. So fresh snowpack, a lot of that solar radiation just gets reflected back out into space. So the more that our snow stays on the ground, the more contaminated it gets, you get more particles within it, the less reflective it becomes. So the fresh snow, highest albedo, all of that, or pretty much all of it, just gets reflected back out into space, and that contributes to colder temperatures. It's that natural refrigeration factor. When we have a fresh snowpack on the ground, not much energy, not much sunlight can be absorbed by the Earth's surface, so therefore our temperatures are usually colder with fresh snow on the ground compared to a bare ground surface. Now, specifically focusing on cloud albedo, I talked about high clouds versus lower, thicker clouds. It depends on how much water is in the cloud. More water, you have a denser cloud mass, that's a higher albedo, more reflected energy back out into space. The average size of water droplets, so smaller droplets, is a higher albedo, meaning there's more surface area with those smaller droplets, more light is being reflected. So an example, in fog, if you're driving through dense fog and you're trying to put your high beams on, there's less visibility because more light is being reflected with those smaller water droplets in that dense fog. So when we have these higher thin clouds, you can think about it as incoming radiation coming from the sun. A lot of it just passes through those higher thin clouds, and we can get a warming effect here at the surface. Versus lower clouds, that can reflect a lot of that sunlight coming in from space, and we can usually see cooler than normal conditions here on the ground under those lower clouds. A similar effect happens with outgoing radiation coming from our Earth's surface. the high clouds can trap that during the daytime. So a little bit of an interesting effect with the cloud albedo. So now we just had the vernal equinox, the first day of spring, when our sunlight was directly over the equator, all areas receiving about 12 hours of daylight on the first day of spring, which was on Monday. And another thing that you'll notice, now that we're in towards the March time of year, our sun is getting higher in the sky. And even with our temperatures well below freezing, that higher sun angle can melt all that fresh snow that we have on the ground. So in December, near the first day of winter, our sun angle at this latitude is about 20 degrees. We come towards this time of year, 43 degrees, and then by the summer solstice, about 67 degrees in the sky. So closer to the equator, you have a higher sun angle versus we're at a higher latitude, so our sun angle doesn't get as high in the sky, but the light hits the snow more directly, so that can allow our snow to melt quicker, and that's why we're seeing a little bit more melting, even though our temperatures are still remaining below freezing. So as we get closer and closer to summer, our June sun rays, when we see that summer solstice, will have the sun highest in the sky, and the energy received at any place and time is proportional to that sun's angle. So when it's the highest in the sky, we can absorb the most amount of sunlight, get that most radiation, allow for the snow to melt a lot quicker. So some interesting stuff about both sun angle and albedo, why you need to have those sunglasses on when it's really bright outside with that fresh snow.
And you're a skier too,
Yeah.
so you know in the winter, you get that reflectivity.
Might
Give
need
you a
some
sunburn.
sunscreen. Yeah.
In the
exactly.
winter, right? That's that concept.